Good morning to one and all. I welcome you all for the today's morning session for metal cutting and forming. I'm Professor Raju Patil from Mechanical Department, Angli Engineering College, Belgavi. So today I will be conducting on module 2, that is milling and drilling. Okay. Next, before going to the syllabus, we'll be discussing about this some briefly about the syllabus, what the module 2 contains. So here you all can see the milling, various milling operations, classification of milling machines, vertical and horizontal milling, up milling and down milling, indexing, need of indexing, simple, compound and differential indexing. Okay. And after completion of milling, we'll be dealing with drilling, difference between drilling, boring and reaming, types of drilling machines, boring operations and boring machines. After completion of drilling, we'll be dealing with shaping, planing and slotting machines, machining operations and operating parameters. And after completion of this we'll be dealing with grinding, that is under grinding it comes grinding operation, classification of grinding processes, cylindrical, surface and centerless grinding. Okay. So first of all we'll get to know that is what is milling machine. Milling machine is a machine tool that removes the metal as the work is fed. Okay. Milling machines are widely used in the tool and die making industries and are commonly used in manufacturing industries for production of wide range of components. Typical examples are milling of flat surface, indexing, gear cutting, as well as cutting of slots and keyways. We use most probably widely these milling machines for slots and keyways. Okay. Milling is a metal removal process by means of using a rotating cutter having one or more cutting teeth. Next we'll come to milling methods. Milling methods, there are two basic methods: up milling and down milling. Up milling or conventional milling, down milling or climb milling. Up milling or first of all we'll deal with up milling or conventional milling. So up milling or conventional milling is nothing but a metal in which the metal is removed by a cutter rotating against the direction of the travel of workpiece. Okay. Listen carefully. The metal is removed by cutter rotating against the direction of the travel of the workpiece. And here it needs stronger holding of job, and chip thickness is minimum at the start of the cut and maximum at the end of the cut. Listen carefully, this is very important while comparing up milling and down milling. What see the C point, that is I have mentioned that in up milling the chip thickness is minimum at the start of the cut and maximum at the end of the cut, and this varies in down milling. I'll be showing you all. Disadvantages: tendency to lift work from fixtures and poor surface finish is obtained due to this up milling. In up milling, what happens? The disadvantage is tendency to lift the work from fixtures and poor surface finish. And next we'll be dealing with down milling or climb milling. You all can compare the difference. You all can differentiate up milling and down milling by this. So metal is removed by a cutter rotating in the same direction of the traverse of the workpiece. In up milling, what we used to do, metal is removed by a cutter rotating against the direction of travel of workpiece, and here metal is removed by a cutter rotating in the same direction of the traverse of the workpiece. Okay. And you all can see the second point, that is B point, teeth cut downward instead of upward. Okay. Chip thickness, listen carefully, chip thickness is maximum at the start of the cut and minimum at the end of the cut. So what we have seen in the up milling, chip thickness is minimum at the start end of the cut and maximum at the end of the cut. And here in down milling, chip thickness is maximum at the start of the cut and minimum at the end of the cut. This is the difference, and less friction is involved and better surface finish is obtained compared to this up milling. Okay, and less power consumption is also obtained compared to this up milling. Okay, you all can see the sketch here, down milling, and the arrow mark shown in the down milling and arrow mark shown in the up milling or conventional. Okay, the cutting edges takes full thickness of cut at entry and exits at zero thickness. It is shown in the figure, you all can see. And direction of the force, you all can see the direction of cutting force is shown in up milling in this way and down milling. Okay, next, classification of milling machines. The milling machines may be classified in several forms, but the choice of particular machine is determined primarily by the size of the workpiece. So what it means, depending upon the size of the workpiece, you are going to choose the milling machine type which you are going to select. It depends upon the size of the workpiece you are going to machine. Okay, so first is column and knee type milling machines, and second one is planar milling machines, and third one is fixed bed type milling machines, fourth one is special type of milling machines. So first of all, we'll go ahead with column and knee type milling machines. And column and knee type milling machines is subdivided into uh, subdivided, that is, first one is hand milling machine, universal milling machine, horizontal milling machine, vertical milling machine, and second one is planar milling machine, and third one is fixed bed type milling machines. This fixed bed type of milling machines has vertical adjustment of work table. Okay, remember, it has vertical adjustment of work table, and it is subdivided into three divisions, that is simplex milling machine, duplex milling machine, and triplex milling machine. And special type of milling machines, you all can see rotary table milling machines, planetary milling machines, profiling machines, duplicating machines, pantograph milling machine, continuous milling machine, drum milling machine, and profiling and tracer controlled milling machines. Okay, first of all, we'll be discussing about column and knee type milling machines. Okay, so what comes, you all can see the sketch here. It is shown, first of all, the column and knee type milling machine. Under that, the base contains, you all can see the base contains the reservoir and a pump which circulates fluid to the cutting area, that is the base. And second comes column is nothing but the main part of this machine, you all can say, or heart of the machine. Column is a main casting of milling machine known as column. It encloses and supports all the parts of a milling machine. Okay, and knee, next comes knee, the unit attached in front of the column. It moves up and down on sideways and encloses feed change gearing mechanism. Okay, and next comes table. It is attachment provided at the top of the knee. Okay, it is used for holding workpiece for machining and can be moved in longitudinal as well as crosswise direction. That table can be moved in longitudinal as well as crosswise direction. Okay, and next comes the very important thing, that is spindle. It is the large shaft located at the top of the column. Okay, having tapered in front of it. Tapered hole is used for holding arbors and cutting tools. Okay, next comes overarm. What is overarm? Portion at the top of the column above spindle is called a overarm. Overarm is used for supporting arbors and can be moved forward and backward. And what is saddle? Saddle, you all can see, saddle is which is exactly mounted on the knee, which is the guideways provides cross movement of the table. Okay, next you all can see this, and general purpose you all can see column, spindle, cutter, table, knee, base are the common parts of the vertical and horizontal milling machines. In horizontal, arbor supports the cutter and overarm supports the arbor. In vertical, milling cutters can be mounted directly in the spindle. The milling machines having only the three mutually perpendicular table motions x, y and z axis are called as plane, column and knee type. Vertical type is especially well suited for face and end milling operations. Okay. Next we'll be dealing with classification of column and knee type milling machines. Under column and knee type milling machines comes hand milling machines, horizontal milling machines, universal milling machines and vertical milling machines. First of all, we'll be discussing about horizontal milling machines. The horizontal milling machine has a spindle that is parallel to the shop floor and an overarm that extends over the workpiece. The overarm supports the arbor which holds the milling cutter. On the horizontal mill, the arbor is component that rotates the milling cutter. You all can see the parts given. This is the front view and this is the side view it is drawn. You all can see the table, and you all can see here the arbor bracket, and the arbor is the main part over here, and machine wise you all can see machine wise, and the cross traverse handle and the knee which is below the table you all can see. Okay, thank you for the today's session. If you have any doubts you can call me. Okay, feel free to call. Okay, thank you for the today's session.